Okay, everybody. So I'm gonna make another video to talk about assignment 5 hints. So this assignment covers lecture 17 to 21. Okay, so starting from discrete probability distribution until the concept of some continuous probability distribution. Okay, so basically Gaussian normal, gamma, chi-square on this lecture. So you may need to open up all the lecture notes of FCT. Okay, so 17, 18, 19. So there are 5 lecture notes there, right? Okay. So let's take a look at these assignments here. First assignment. Yeah, so the first assignment here is actually fairly easy. So that's how you determine whether each distribution is a probability distribution, right? What constitutes a probability distribution? Now, if you look at this one here, A, B, C, D, the first 3 apparently they are discrete probability distribution, and then the fourth one is a continuous one, right? It's a continuous random variable. So what constitutes a probability distribution? For discrete one, right? The property says, you need to have this one here, right? For any possible value x, okay, so the total or the sum of the probability distribution, okay, is equal to 1. Okay, so that's for discrete one here. Okay, and for continuous one, right? Instead of a summation, then you do integration. Okay, that equal to 1. Okay, so if you can find any one of these satisfy these 2 properties, that means it's a probability distribution, right? Okay, yeah. So let's take a look at the first one here. So what is the probability distribution here? Here's the probability distribution. For x equal to 1, the probability associated with that is 1/4, 2 1/8, 3 1/16, and 4 9/16. So add them up and see if they're 1 or not, right? And second one here, same thing. Add them up, okay? And third one, same thing. Add them up. Now, you probably will find yeah, this one here. Okay, so for example, right, if this one here, if I add all the 4 numbers up, okay, so what would that be? That's that's 1. Look, that satisfies this condition here, right? So you might say, okay, here this is a probability distribution function. Well, but hold on a second, that's not the only one that you're talking about here. The other property for probability distribution is it cannot be, right? It cannot be actually greater than 1, and actually it cannot. It also cannot be less than 0. So this f of x, right? Okay, it is always between 1 and 0. Okay, so this is not. Okay, yeah. So how about this part D, the continuous one? So we need to check this integration here. So now you probably this check integration here. This is a piecewise function, right? It's not easy to integrate because you need to find each segment of equation here. However, mathematically, you know that what does this mean, right? The integration of this one from negative infinite to positive, basically for this question, is from 0 to 3. So what you're trying to look for is, right, is you're basically trying to look for the area underneath this the trapezoid, right? You call it trapezoid, yeah. So how do I find the area? Then that's pretty easy because you have all the coordinates here. This is 1 and this is 0.5. So add the three areas up and see if that's the one, and this question is 1. So that's why this one is a probability distribution function. Okay, yeah, so that's the part, the first question here. It's the first question. Okay, yeah. Okay, so let's take a look at the second question here. Okay. If you require, you need to look at the lecture 17. Okay, you look at lecture 17 to find out more properties, okay, associated with discrete and continuous probability, and also the concept regarding a cumulative distribution function, right? Which is the one that we're going to deal with, the second one, problem 2. Okay, so problem 2, look at that. The probability distribution function or density function is basically the one I'm giving over here. Okay. More precisely, because the probability density function normally is a name of associated with the continuous random variable, right? Okay, probability density function. Probability mass function is a name associated with a discrete random variable. Okay, so but if you can always just a probability function, that's fine. Okay, but if you want, so probability mass, okay, function, and that's for discrete, okay, random variable, right? Okay, just on sideline here. Okay, so what do we want to do? We want to it asks you to write down the piecewise function f of x. This really has nothing to do with probability. Just give you this function, asking you, can you write down the piecewise function? Second, find the cumulative distribution function CDF of this one here, and then find the probability of this, find the expected value and or mean, okay, of the random variable, find the variance and the standard deviation of the random variable x. Okay, yeah. So let's take a look at the first one here. What's the piecewise function of this f of x? This is actually part of the exercise you probably done in 246. So piecewise function, right? First for this is your f of x, right? This is how we write piecewise function, and you start with here. So okay, this is 0. Apparently, when x is less than 0, and your f of x is 0, and when x is between 0 and 1, right? And what do you have? It's a straight line here, right? That's a straight line. And what's the line equation in here? Right? You have the slope, which is 0.5 over 1. Yeah, the scale is not that great, but it's 0.5 over 1. That's slope. So what would that be? 0.5x, right? And between 1 and 2, okay, and you have a constant. Okay? And between x2 to 3, yeah, that's another straight line here, right? Another straight line. What's this straight line equation? Okay, well, line equation is y equal to mx plus b. Okay, so m is the slope. So for this particular case, m is 0.5, right? Okay, so what would be the intersection? B is the intersection over there, right? And when x is 0, y equal to b. But in this case here, it's hard to tell over there, but we do know is when y is 0, x equals 3. So y is 0, x equal to 3. So basically that means 0 equal to 0.53 and plus b, right? So b equal to negative 1.5, right? Yeah. So oops. Yeah. So that's what you have here. So that means sorry. What's going on here? So sorry, no. The slope is now 0.5. Okay, slope is negative 0.5. So negative here. So b is actually equal to 1.5. Okay, yeah. So that's what's b value. So now you have the piecewise function for this portion here. Okay, so then when x is greater than 3, basically 0, right? Okay, so that's piecewise function. Okay, so why do you do this, right? Why do we want to do this? That's pretty much for the second part. Find the cumulative distribution function there. Now for this portion here, first of all, you need to understand, you need to know what is the cumulative distribution function, right? So if you look at our lecture notes, we use capital F of x to represent cumulative distribution function. The definition of the cumulative is basically the probability of a random variable x less than a certain value of a small x. Right? That's a cumulative distribution function. And in terms of equation, it's from negative infinite to x, and f of x. Let's use u in here and du. Okay, so there's a couple of things you need. So that represents the probability when x is less than this value, and to calculate that, you need to calculate the area from negative infinite to the value of x, right, underneath the curve f of x. So for example, if x is over here, then you're looking for the area until this stage. If x is over here, then you look in the area until this stage. If x over here, then you're gonna x over here, right? So now you probably say, oh, right, you know, because when x is over here, if I want to calculate the area from here to here, so what do I have to do, right? I need to basically separate this calculation area to integrate from here to here first, and then from here to here, right, to calculate the area. So that means the part A results, the piecewise function will come into handy. Okay, so do that. So basically what you need to do is, right, you need to take a look at different cases. For example, so instead of this, your f of x will also become a piecewise function. If x is less than 0, right, what is f of x? Apparently if x is less, that's basically 0, right? If x is within this range here, right, and what will be your f of x? Okay, yeah, so your integration becomes, right, basically becomes 0 to 1 now. Not to 1, sorry, to x, right, 0 to x, and f of x, well, and f of x dx. But then what's the f of x value between 0 and 1? Look at that here, oh, 0.5. Okay, x, 0.5x. So integrate this one here, apparently you'll be able to do that. Okay, so now you keep continue. That's how you do to find the cumulative distribution function for each segment. Okay, for each segment there. Okay, for some segment, for example, if x is within maybe over here, right? So you're gonna probably have to integrate from here to here first, then to here to here, and then from here to here, right? So 0 to 1, 1 to 2, 2 to x. Okay, so that's what you do. Part C. Let's see part C. Find the probability p x from 1 to 3. Where's 1 to 3? Oh, 1 to 3 from here to here, right? The probability from here to here. So according to the way that we just calculated here, so the probability, right? Right. Let's move down this a little bit here. See, so probability 1x3. This is capital X. Yeah, so basically it also equal to basically probability capital X less than 3 minus probability capital X less than 1. The equal sign doesn't matter. You can leave the equal sign here or get rid of the equal sign. That's okay, right? In terms of the function here, it's basically integral to 3, integral to 1, right? But more easily, what you can do is look at, okay, infinite to 1, that's the area here. Infinite to 3, that's the total area. So basically, when you look at this probability, what you're looking at is the area, right, underneath here from 1 to 3. So you're just looking at this one here. And that's fairly easy, right? That's fairly easy. Okay, yeah. Okay, so, in other words, right, this also equal to 1 to 3 here, right? F of x dx. So one of the property that we learned also in the class is the cumulative distribution function is basically the antiderivative of this f of x. Okay, so you can also see that is f of 3 minus f of 1. Okay, yeah. The last part, D, asks you to calculate the mean value. Okay, the mean value of this random variable. Okay, so let's maybe calculate that purely based on mathematical equation. Okay, so what's the mathematical equation? This is a continuous equation, mean equal to expected value of this. The formula says, okay, this equal to negative infinite, positive infinite, x, f of x, and dx. Okay, so apparently you can see that because it is a piecewise function, and what you need to do is you need to integrate it from 0 to 1, from 1 to 2, from 2 to 3, right, like this, right, do the integration. Okay, so you'll find the value 1.5. okay, yeah. Now let me show you another way of understanding this problem in here. So let's just say I have a piece of wire. Okay, let's say I have a piece of wire from 0 to 3. Okay, this is a piece of wire 0 to 3. Well, I'm gonna consider, okay, I'm gonna consider this f of x. Okay, I'm gonna consider this f of x, right? So called, see, what will be the density? What will be the density of this piece of wire? So let's consider this f of x a density here. So that makes sense. You see, we call it probability density, right? But let's consider this the density of this material here. So the density of the material is like this guy here, right? It's like this. Okay. So this density basically represents the density at each portion, at each location in the wire. Okay. Now, what we're looking for is, right? What we're looking for the integral of x, f of x. Basically, right? This is like a weighting function on the x. So you're looking for is what's the centroid? Okay, what's the centroid location for this piece of wire, right? Now, the centroid location here is due to your mass distribution here, right? Mass density. And for this question, the density distribution is a symmetric one there, symmetric. So very naturally, you see, the centroid of this piece of wire must be in the center, right, of this wire, which is basically what you get is the x bar at here, right, the average value x bar here, and apparently, of course, that is 1.5. Okay, so that's a quick way of calculating that. The E part, okay, the E part, you are supposed to calculate the variance, or standard deviation. Well, standard deviation is the square root of variance of this random variable. Okay, yeah. So again, purely formula, right? Sigma square. Sigma square, the formula, right? What it says is expected value, okay, x minus mu square, like this. Okay. So negative infinite to infinite, and x minus mu, okay, square f of x. I'm trying to change that to small x here, okay, and dx. Okay, so that's the pure formula here. So you can see, oh, well, let's just integrate separately, right? But in the class I mentioned, when calculating the variance, one way to calculate is this, but the other way, there's the alternative, is to calculate this way here. Okay, so sigma square also equal to this. And what is expected value x squared? So that's basically just x squared f of x and dx. Okay, So what makes this more convenient than this one here, apparently, because there's x minus mu square here. You need to expand this and then do the integral, right? But this one here doesn't. It's just x squared here. So you might make the calculation a little bit more simplified here. So this is just 0 to 1 plus 1 to 2 plus 2 to 3 and minus mu squared. Okay, so that's how you calculate the sigma squared. Okay, so you can use a maple if you want, to verify this calculation, right? Yeah. So that's number 2 question. Okay, so let's take the number 3. Number 3 is actually pretty easy. You can use Excel or you can use a table to give it to you to do it. Okay, so here's a table here, right? Here's a table. Okay, so what I want you to do is just basically calculate this separately. It's a kind of exercise, basically this one here. This part exists on continuous variable, and this is basically exercise on the discrete variable here. So x is given here, population 345. Probability distribution for 345 is also given there. So what you do, just rewrite based on the information there, okay? And then x multiplied by this give this, x squared multiplied by this give summation, all right? Yeah. So this will be your mu, right? This will be ex squared here. You're required to take sigma square, and I guess right? And you get that, okay? Is this number right? Yeah, okay, so that number is okay. Yeah, okay. Let's look at problem number 4. Okay, so problem number 4, I think relates to lecture 20 and 21. Okay, so in 2021 we started to talk about different continuous distribution function, and in particular the one that the most important one is the Gaussian distribution, or the so-called normal distribution, right? And we also talk about when we calculate the probability based on this normal distribution, we don't calculate, right? We don't calculate the integrals or whatever based on the normal distribution. We calculate, okay, the z-score for the normal random variable x. So the normal score is z-score is z equal to this. So we calculate the probability based on this conversion at here. We can use Excel. We can also use the table, right? So we'll try to exercise this basically through this question at here. This is a similar example that I went over in class, but some numbers are different here. The process manufacture ball bearings, okay, whose diameter are normally distributed with a mean of 2.5. So mu equal to 2.5. Standard deviation is sigma. Specification call diameter to be in the interval of this much here. So what proportion of the ball bearing will meet this specification, right? So that's the interval at here. Okay, so assume the ball bearing manufacture process can be recalibrated. To what value must the standard deviation be lower so that 95% of diameter will meet the specification? Okay, so essentially this sigma here may not be good enough, huh? So first one here, this is the keywords, right? Specification called diameter to be in the interval of 2.5 plus minus 0.01 centimeter. So this means here, is you want your ball bearing, okay, to be within this interval. So that's basically 2.49 to 2.51, right? Then as what's a proportion? Proportion basically the probability idea. Basically, the question becomes, what is the probability, right? If I use capital letter X to represent the ball bearing diameter, so what's the probability of X to be inside this interval at here? There. So you need to find this, right? You need to find this. Well, as I mentioned, I don't try to find the probability of this in terms of the probability distribution. Basically, I know this is a normal random variable, right? So I know the function f of x distribution associated with that. So if I calculate, really, I need to calculate. I need to calculate this and then subtract this, right? But I said I don't want to calculate. I use the z-score. So what's the z-score? Z-score is x minus mu over sigma. Okay, so then apparently you have two values here, so I need to calculate two z-scores. So first is z1 here corresponding to this. What's mu? Mu is what's that? 2.5. Sigma is this, and the other z-score is this. Okay, so this value, you calculate that. Let's see what's this value here. You get it. I just want to show you how do you how would you use this is equal to negative 1.25, okay, and that equal to 1.25. So let's see, right? This is basically now then your question, right? Your question in here becomes this, as we said, the probability of this equal to the probability of this. This is a capital letter Z, okay? That's a small letter Z, okay? So okay, there's some noise there. Okay, it's making noise. Okay, all right. So and the probability of this equal to the probability of Z less than this minus the probability of this less than this. Okay, so I'll show you how to use the table to find the values of this. So here's a table that you will find on the WebCT. Okay, so what this table gives you is the so-called the left-tailed value. Basically, you look at this purple area, right? So this purple area means here the probability of z less than a certain value, small z. That's the area underneath the curve. So what do I have here? 1.25, negative 1.25. So let's look at the table here. 1.25, 1.25. 1.25, look at this one here. 1.2 1.2. I don't have 1.25, do I? Well, I guess, yeah, this is, sorry, 1.25. Yeah, here I have 1.25. Yeah. 1.25. There we go. Here. So you get 0.89435. Okay? Yeah. So 0.8944, that's fine. Okay. So this is 8.8944. And then z minus that, let's see. Negative, where's negative? Negative is top there, up there. Negative 1.25, negative 1.25. Go. There. So use a ruler. 0.1057. Or I'm trying to use a 6. So I anyway, a 7 here. Okay. So they subtract that. That's basically what you get here. Okay. Yeah. You can also use Excel to do this, and there's absolutely a more accurate if you use that value to do this. Okay. Yeah. So the second part. Okay. Second part, let's see. Assume that the ball bearing manufactured to be recalibrated, to what value must the standard deviation be lowered so that 95% of the diameter will meet the specification? Okay, so this one here is actually a reverse problem at here, right? Reverse problem. So the keyword is 95. Okay, the keyword is 95. Now let's start from the Z value, the standard value Z. Okay, and we know it's a normal distribution with Z basically with a mean of 0 and a variance of 1. So I ask for basically ask for the interval, right? Span 95%. So 95%, right? 95% is what in terms of Z score? So somewhere here, and 95%. Okay, yeah. Now, because we're talking about a symmetric situation in here, right? So it's a symmetric. The value for the interval of x will be symmetric. So then you know this is going to be the 95% in here, and this is your mean value, 2.50, right? It's mean value 2.50, and this is a 2.49. This is 2.51. Okay, yeah. And we calculate this Z. Yeah, we're gonna calculate this one here. So this is 95%, right? We want this one to be 95% of area here. So originally it's not gonna be 95% with the sigma. With the sigma of this, it's not gonna be 95%. Okay, so what that value here, right, will give you, this is 0, right? What that value here will give you 95%. Okay, that's a question here. If this is 95%, now we know that the overall area underneath the curve is 100. So the portion over here plus over here will be just 5%. And because it's symmetric, basically, you're going to have 2.5% here and then 2.5% at here, right? So let's see here, right? This is 2.5% up to this point here. So now it's easy to use the table. Let's say 2.5. Where's 2.5? Let's look for 2.5%. So 2.5% and 0.2. Sorry, 0.2. Where's 2.5? Here. Yeah, here. Right, 2.5. So it's negative 1.96, right? Negative Z value, negative 1.96 results an area to the left of 0.025. So this is negative 1.96. So what about this value here? Well, because this is symmetric, apparently this is going to be positive 1.96, right? Positive. So now you have Z1 here, Z2 here. Okay, yeah. Now, how does this negative 1.96 relates to this x equal to this and x to this? The Z score, right? The Z score, because we know Z equal to x minus mu over sigma. Okay. So negative, you can use either one. Negative 1.96 equal to 2.49, okay, minus mu 2.5 divided by sigma. Okay, so solve for sigma, you get new sigma here that's supposed to place 95% of your ball bearing, okay, within that range. Okay, yeah. Okay, so that's question number 4. Okay, question number 5. Yeah. Company pays its employees an average wage of $15.9 an hour with a standard deviation of $1.50. Assume the wage is approximately normally distributed. Find find what percentage of worker receive wage between this and that an hour inclusive. And the highest 5% of employee hour wage is greater than. So I think the first one is fairly straightforward, and you can calculate that. Okay, like that. So what you need to do is you can let the average wage, and it's just not average wage. So let's let the wage equal to x, right? And the wage, okay, hourly wage, I guess. So then the A part you're looking for is probability of x within this range. Okay, and this is your mu here, that's your sigma at here. Okay, so mu equal. So then, according to the process that we were just talking about in the previous lecture, you can see that. So let's just take a look at the second one, the wording here. The highest 5% of the employee hourly wage is greater than the what amount. Okay, and again, this is a sort of a inverse problem again. Okay, so what you're looking for, right? What you're looking for is the probability of x greater than certain value equal to, okay, 0.05. So that's what the question here. What month? So you call this x small 0 here. Okay, x naught, right? What would be this value so that the probability x when greater than 0.05? Okay, yeah. So now what the question is saying is, I'm not gonna try to find x naught directly, right? So I'm gonna try to find indirectly. So let's try to find maybe okay, this small z not at here. Okay, and then go use the z-score equation, okay, to find the x naught, right? So it's actually pretty easy. What value produce z greater than z naught, right? So let's look at the z table here. So yeah, so maybe go back here. So this equal to that, which means what? Which means the area. Okay, so z naught here. So this is 0.05 here, right? So then all the outside here is what? 95%, right? 95%. So when you look at the table here, you need to look for the 95%. 95%. 95. Close. Yeah, here, right, 95%. Okay, so there's not exactly 95 here. So we need to look for the one that is the most close to 95%. So this is probably, this one here is closer to 95% here, right? The corresponding z value is 1.64. Okay, so basically saying z naught is 1.64 approximately. Okay, if you use Excel, you actually is 1.645. Okay, yeah. So once you find this z naught, then z naught equal to x naught minus mu over sigma, then you can find x naught. So that'll be the value over here. Okay, yeah. In terms of using Excel command, you need to look at, you can look at my lecture notes. I have some examples of using Excel commands in terms of finding this thing here. Okay, it's basically norm s inv, or sometimes a norm s dist. Okay, so these two functions. Okay, that's the function in 2010 Excel. In 2007, it's no s here, just norm inv, norm dist. Okay, let's see problem 6. Problem 6, you have to look at lecture 21. Okay, lecture 21, because we're talking about gamma distribution and here, right? Gamma distribution. Now, gamma distribution is a very interesting distribution because it leads to the chi-squared distribution, which we use in the future. This is a gamma distribution here. Okay. Now, I'm not asking you in this question to integration or to operate on this one here. I'm asking you to use Excel, I think, to do this question, right? What is the problem? Did I ask you Excel here? Okay. Yeah, you should try to use Excel here to use this one here. Otherwise, it's a little bit too much. Okay, yeah. So use Excel here. Use Excel. Okay. Yeah, use Excel. But A and B are fairly straightforward. This is your alpha value, beta value. What's the mean survival time? What's the standard deviation survival time? So see, here is the formula. Okay. So here's a formula here we derived in class. This is your mean. This is your sigma. Yeah, that's it. Just use mu equal to alpha beta, sigma equal to alpha beta squared. Okay, so that's the part AB. So part C, what is the probability of this one more than that? So basically the probability of x greater than 30, right? Greater than 30 here. What I want you to do is use Excel. Don't do the manual integration, right? In Excel, the function is called gamma dot dist. Okay, yeah. Now you can use the way to use that is first for 30 over here, okay, and then alpha beta over here. Alpha is 5 and beta is 10. Okay, and then use a parameter called true. True means you're trying to calculate the area, okay, the area to the left side of this value 30. Okay, so gamma maybe the distribution something like this. Okay, yeah, so this is 30 here. So you're to calculate this. So this is give you this guy here, right? But you're looking for is probability x greater than 30. So what you need to do is 1 minus this guy here to get to the area over here. Okay, so that's the question, problem 6. Okay, so that's all the question in here. There's a bonus question for these assignments. This bonus question, you need to watch a video on the YouTube. Okay, not my video. Another guy, who's very good at Excel, posted so many Excel tutorials, and I think they're very good, very helpful. So you can try to look at this video there and to plot the so-called dynamic area chart for normal distribution. So you just change the number for the x, and you can have a dynamic area underneath the chart. Okay, and these are some very useful, nifty things, tips and tricks in terms of using Excel. Okay, so take a look at that. Okay, and there's a bonus point there. Okay, so if you got any questions, let me know. Okay, and hopefully you can catch up. I know some of you being tied up with midterm exams. All right, thank you. Bye.